Hey guys, today we are going to be doing a wind tunnel in Ansys Workbench. Those will be a little tutorial on how to set that up. So, of, as always, we're going to open up our Design Modeler tab in Geometry. Obviously, you can use Space Claim if you want. I just like Design Claim, Design Modeler. So, go to our X1. We're going to do 2D wind tunnel. If you really care, you could do a 3D model. It's not much more different. Just be using either rectangles or circles and extruding. But for right now, we're just doing the basics. Uh, so I'm going to show you a slightly easier way than how I did it. Um, Initially, I had created geometry for a wind tunnel and then had to solve some math to figure out how long my diagonals were going to be so it was symmetrical. We're going to skip all that noise and we're just going to pick a arbitrary point here and an arbitrary point here. So that way it is, for the most part, symmetrical across that line. Um, we're actually going to be using meters today instead of swapping over to centimeters. So, alright, so check our dimensions on this line. Let's just say it's 1 point. With 1.4 meters, that'll make it easy. That's 0.7. Okay, so what we can do here, go to modify, and we're going to drag this up here. We're going to hope that, oh, you know what? Just kidding. We're gonna delete that. Because we're going to use the copy tool instead. Draw a line. Say this. .7 meters, right? And then we're going to modify, copy, paste. Here. And we're going to go drag it there. And then let's just check the dimensions. I'm going to change this to 0.7. Boom. So we got 0.7, 0.7. That's pretty easy. Then let's say a section of line. So we're going to start with a touch it. It is just kidding. Alright, anyway. So we're going to draw a line from our origin. Let's say we want this thing to be I don't know, 1.2 meters long. Doesn't really matter, it's kind of arbitrary at this point. But what we do want is everything to be nice and equal. Let's say this is going to be 0.3 meters tall. Pretty close. Copy that again. see if we can use. Never have any luck with it, but we'll have it today. Nope. Alright, that's okay. We're just gonna drag it. And we'll just redimension that. So I'm sorry if there's a better way of doing this. Please leave in the comments. I'm super used to AutoCAD and DraftSight and SolidWorks, where you can just pick an edge, drag it wherever you want, or draw things that snap from the center line, because that would make sense. Anywho, so we got our geometry. We have this thing that's 0.6 meters. This one's at 1.7 meters. We're just gonna attach this corner to this corner. So we're making a wind tunnel. So this first section is going to be a contraction cone. Um, yeah, so we can have a test section where we have our velocity come in, well, a velocity inlet, where our air comes in, and then we're going to make a diffuser for the air to come out. We're to mention this guy. Say we want this to be. Maybe we need a really long test section if we want to test something like 1.5 meters, right? Condenses really fast. It's a large test section. Now, you know what? Let's make this shorter. Let's make this point. Doesn't really matter. These are all arbitrary, right? Let's go 1. I like 1. Nice and easy. Okay. So then go to modify. Copy that again. Let's paste it here. That one's nice. That one we get to actually have a snap feature. Yay. Okay. And then last little bit, I am just drawing reference lines mainly because it makes it easier on, so I could use the snap features. Okay. And let's say, I don't know, what's the next section? How long we want the diffuser to be wider, bigger diffuser. Let's say this diffuser is going to be 1.5. This will be 1.5 meters. We've got a big diffuser, right? That's cool. Alrighty. So then we want at this edge, let's say it's slightly, oh, I don't know, 1.5. Yeah, let's go with 1.5 instead of 1.7. So it's slightly smaller than the contraction cone. I want this to be 0.75. Wait a second. Made that front section. Oops. We made that front section 1.4 meters, didn't we? Yeah. So let's say this is 0.6, be 1.2, right? That'll make it a little bit better. Smaller diffuser, that's what we want. All right, copy that. Paste this. Cool. Get out of there. This, we don't really reference that anymore. You don't have to have the dimensions there, guys. If you click on the item, you can change the dimensions from there. I just like it so I can kind of have a reference of which things I need to change. So purely up to you if you want to do it that way. Oh, maybe that actually, that'd be nice. 0.6 attached. Cool. All right. Well, worst case scenario, if it doesn't connect, it'll break when we go to do our model, but not a big deal. All right. So we gotta clean this up. We don't want any of these extra lines in here. Not gonna be fun later on. Awesome. Cool. Looks like a diffuser if I ever saw one. Also like a wind tunnel. Yeah, there's different shapes of wind tunnels. Oh, neat. Okay. But anyway, we got a wind tunnel, right? Looks pretty symmetrical for the most part. Same thing as we always do. We're going to click on that sketch. We are going to create, or sorry, we're going to concept surface from sketches. We're going to go ahead and select it, apply, then we're going to generate. Hopefully everything's attached, and we have a, oh, got an error. I think everything was attached. It's our warning. Close profiles. All right, so we forgot to close something up. Probably not those guys. Yep. This little guy right here. It's gonna happen, wasn't it? Alright, that's okay. Drag this guy, click on him. Yeah, see it? Well, it's acting like it's controlled. Like it's attached. Give me 1 second. Alright, sorry, we're back, guys. Um, so all I did was I had to drag this little line down a little bit because the corner was not even a few centimeters above the little snap point. So once you fix that, make sure all the corners are attached, and then you won't have any issues with it saying that it's not closed. Now you have your wind tunnel. It looks, like wind tunnel, I guess, and a little model. Now from here, this is all we need for our geometry. If you get super interested and want to do testing on things, and you want to like toss a airfoil in here, or a bullet, or a truck, what have you, you can import files in here if you so choose. You can import different types of shapes if you don't want to have to design it yourself. But you can also draw your own things. So you just go back to sketching, and for our purpose, let's just make a circle. The way to do this and have it like say by tangents. Yeah, that's fine. Let's do it here. But you don't want to make it too big. You want to make sure your model is much smaller than your cross section here. Alright, so now that you have that in there, you just hit generate again, and it will just add that little model in there so you can see how it'll function in your wind tunnel. That's it for that. So close that up. I think now's my favorite part, meshing. So jump in here. Now, if you're on the student version like me, you got to keep the elements below 512,000, I think. something like that, 512,000. We're not going to do anything crazy. We're going to add a couple meshes. Um, I'm going to do a face mesh. I'm going to do just a regular automatic method and then a refinement. Uh, you can add inflation to the shape if you really want to. Oh, there we go. Okay, this is the geometry I want. And we're actually, because we're not doing a square like we were last time, or a rectangular section like we were the last few times, we're going to change it to triangles. So that way it represents our geometry a little bit better. There we go. Okay. And we're just going to hit generate after we add those two meshes. And looks pretty cool. But that's not what we want. We want at least 100,000 or 100,000, yeah, 100,000 nodes or so. Um, so that's really easy. We're just going to change element size to, let's say, 0.02 and generate. And that should, maybe. Let's increase this to 3. Alrighty, that's I want these edges to be a little bit nicer. Give me 1 second, guys. We'll be right back. Alright, guys, I'm back. So, sorry about that. I actually just deleted the refinement and we changed the element size to 0.001. So now we have a very fine mesh. So hopefully this gives us some good data. I think it's within the realm of 512,000 elements that we're allowed to have student account, so we should still be good. And one thing before we forget, we need to create our name sections so that way we can see that in our calculations. We're going to do the boundaries. Oop. Remember we did 2 lines on each side, so have to. You can go back and change this to 1 single line if you really want to, but you just select both of them. Do the inlet. Say don't make it harder on yourself if you don't have to. Outlet. Let's call this our model. Bam. Alright. We got boundaries, inlet, and outlet, or inlet, outlet, and the model. That should be all we need for geometry. Let's go ahead and update that. Now, one of the things we're going to care about in our setup is we want to see some temperature change to kind of help explain high pressure and low pressure and what that does to our velocity. As we should expect a constant temperature throughout our wind tunnel because you look at the, oh man, well, yeah, as you look at the Reynolds number, the Reynolds number doesn't really have a function of temperature, um, but it does have a function of viscosity or pressure and, or sorry, velocity. So if our uh, turbulence increases because of low pressure zones, um, giving us favorable flow, our velocity should increase. So we'll see that when we calculate this. In general, we don't really need to change any of this. Uh, go to models because we want our temperature, we want our energy equation, and we want to change this from viscous to a K epsilon 2 equation. We want enhanced wall treatment, pressure gradient effects, and thermal effects, as well as viscous heating. That should be good there. Materials, we're just going to use this air. That's a wind tunnel. That makes sense. Obviously, if you are using another type of uh, gas or liquid going through your wind tunnel, you can do that. Don't really need to do too much else. We do need to change our boundary conditions and have our inlet. Let's go with 10 meters a second. That makes it really easy to calculate. We don't need to change any of the boundaries. Our boundaries are stationary. Um, that is how our wind tunnel is going to work. And that's pretty much it. I have found that the number of iterations 10 isn't always the greatest for certain things that you're doing, especially when your meshes are super fine. Um, initialization doesn't quite hit the, I think it's like 10 to the negative 6 number for convergence. We want to see this O1 turn into an, I did something wrong. Okay, well, we're going to run it. We're going to see what happens. Right, we want to go 1,000 iterations. All right, go ahead and calculate. All right, so fixed a couple things and changed the model a little bit, guys. My circle was giving me issues and wasn't allowing me to reach a solution calculation. Um, that's probably just on my part. I made the circle a little bit too big and it was messing with the cross section, or maybe my edges weren't closed again. So um, went back, pulled the circle out, and then remeshed it. Um, it calculations ran just fine. To show you what that looks like, go ahead and create some contours. Let's just say this is our contour. Velocity map. Oh, you know, fine. Body. There we go. And that looks pretty much what you'd expect. So as it enters or finishes through the contraction zone, speeds up a little bit. See that by adding another contour. Yeah, so pressure changes, increased pressure. Just kidding. That's pressure decrease, favorable flow condition. Yeah, so pressure decreases. Pressure decreases. Our velocity increases here. So, also add another contour for temperature. See how that looks. And that looks right. Should have fairly consistent temperature across the board. It looks like it's changing, but this is 300, this is in Kelvin, 300 degrees Kelvin. So it's 300 exactly, and then 300 and maybe 0.4 degrees Kelvin. So not a whole lot of temperature change. This is probably due to mesh, maybe some weird boundary conditions, and that's fine. Um, I think we have the uh, like the viscous temperature option turned on, so maybe that's causing it. So that's that's pretty much it. We can add some plots in here just to show what that looks like as well. Um, so instead of having to go into uh, the results section to create all these, you can actually skip a step and do most of these in here. Um, that's personal preference, however you want to do it. This one's kind of nice because you get a little bit of everything. This might not work. Plot that. So it looks a little goofy. These are our thousand data points. We could put a center line in this model and take it off the center line. See if we do that real quick. All right, so sorry, it's in results, surface, create, line, and rake. It's called the center line. As a line. And then our x, it's going to start at 0, and our total length from our plot looks like 3.75 total length. So you can put 4. It's not going to make too much of a difference. There's going to be some weird math at the end. So as it gets to 4, it'll kind of do a weird cut. That's okay. And then we can actually use 0. Oh, sorry. Actually, I had changed my line in the geometry. So I need to do the center of my initial line. So that height was 1.4. So we want 0.7 for our y1 and y not heights. Oh, okay. Let's do, oh, there we go. Okay. So I put it too high. That's all right. Now we have a line in our model. Uh, uh, so line 5 goes straight through the middle of this mesh right. Anywho, so velocity contour. Run this and see if that changes at all. Shouldn't. This is going to be mainly for the plots and where it takes that. There we go. So it looks a little bit nicer. So from that center line, it'll give us that velocity. And then same thing, we a pressure from center line. And these should, the velocity plot, well, the velocity plot and the pressure plot should be inverse of each other. So display that. So that looks pretty much inverse of each other, what we were expecting. We'll add one more for temperature, and that one should look like a straight line. Plus, so it's a little goofy. Obviously, the range at which we have kind of gives us some weird values, but for the most part, it's a straight line. Some weird jumps in between. Not a big deal. That's really based off of how you set up your parameters. If this was really curly, if it looked like a like a quadratic or something like that, or any kind of polynomial that wasn't like a linear, either a linear increase, kind of like this, it should be mainly a straight line. But this doesn't exhibit any weird behavior that might suggest that you did your experiment wrong, just that the parameters are a little maybe underdefined or something. So that's pretty much it for this. Thanks for watching, guys. If you have any comments or questions, just leave them in the comments below, and I'd be happy to read them. All right. Have a great day, everybody.